Happy Friday, everybody. So, moving into next week, we're going to start talking about multi-step equations and solving multi-step equations. So, let's go back this week and let's review some of the stuff you did in grade 8, namely solving single and two-step equations, what it's for, what the variable x really means, so that we have the skills to build on them so we can talk about distributive property, expanding, and simplifying next week. So, what is x? That's what algebra is all about. Algebra is all about what does x really mean and why do we use x? We use x because we either don't know what the number is or it could be a bunch of different values. And so we use x to represent a range of values. But let's talk about the simplest case. Let's just say x is equal to 5. Well, x is an unknown, but I know that through this equation, x is really equal to 5. We can step it up a bit and we can make it a bit more complicated by saying 2 plus x is equal to 5. Well, I don't know what x is, but I have some hints. I have this equation that can help me determine what x really is. And here I know that 2 plus something, whatever this is here, is going to give me 5. Well, I know intuitively that 2 plus 3 is 5, and so my x here is probably going to be 3. And that's using intuition to figure out what the variable is. So let's do that. Let's use that same skill, but let's talk about the classic example of scales. Scales is a great way to represent an equality or an equation because everything has to be balanced on the scale, just like everything has to be balanced in an equation. And on this scale on the left side, I have some cubes. All of these cubes weigh the exact same amount. So I have a bunch of cubes on this side, and I have a few cubes on this side. But on the left side of the scale, or on the left side of the equation, I also have 2 brown paper bags. And in these paper bags, I have a certain number of cubes. Both bags are the same. So they have the same number of cubes in each bag because they're both represented by the same variable. But what I really want to know is how many cubes are in each bag. And I have some hints. I know that the number of cubes in this bag plus the number of cubes in this bag plus these 3 cubes here is equal to the mass of the cubes on the right side. So if I want to figure out how many cubes are in the bags, it would be useful if I could eliminate the cubes that are on this side so that I only have the bags left over, because these cubes outside of the bag are really complicating the issue. So let's get rid of those altogether. I'm going to delete these 3 cubes. But if I just lift these cubes off the scale, suddenly this scale will weigh less on the left side than it does on the right side, and the scale will be off balance. So if I'm going to lift 3 cubes off the left side, I have to also take 3 cubes off the right side so that everything stays balanced. So I have 3 fewer cubes here. I have 3 fewer cubes here. So let's actually get rid of them all together. And what I'm left with is 2 bags of x's here and 4 cubes on this side. Well, I can pretty much figure out how many cubes are in each bag because I know that these 2 bags hold the same number of cubes. And if these bags hold the same number of cubes, there must be, between both bags, 4 cubes, because there's the same number of cubes on the left side as the right side. And we can assume that the paper bag itself weighs next to nothing. A paper bag weighs so little that we can consider it weightless for this particular example. So if I have 4 cubes in 2 bags, I can divide that by 2, and I know that there's 2 cubes in each bag. And that's really how algebra works. If we go back to what it was before we eliminated the cubes, I can write this as an algebraic expression. I can say that I have 2 I can't go back any further. So I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. 4, 5, 6, 7. 3 on this side. So I can write it as, so this is 2 bags of x. So I have 2 x's. That's known as 2 times x. This is my equation here because that represents the 2 sides. So I have 2x plus, I have 2 bags of x plus these 3 unit cubes here. On the right side, I have 1, 2, 3, 4, 5, 6, 7. I just have 7 unit cubes there. So, writing this as an equation, I have 2 bags of x plus the 3 cubes is equal to 7 cubes. Let's return to this, and we'll solve this. But first, let's solve single-step equations through intuition, and then we're going to do it using the algebra. So here I have x minus 4 is equal to 7. So x minus 4 is equal to 7. What can I get? What number can I have that when I take 4 away from it, I get 7? Well, I'm pretty sure that's 11. And I can double check that. So 11 minus 4, that equals a 7. Yeah, that's good. So it's 11. Moving down, x divided by 4 down here. So I have x divided by 4. What divided by 4 is equal to 25? Well, I know that. I know that it's 100. And I can test that 100 divided by 4 is equal to 25. So I know that works. And then down here I have 3 times x. Recall that whenever I have a constant or a coefficient and a variable here, so a number and a variable together, that really means multiplication. We use sometimes a dot to represent multiplication. We don't use the typical multiplication symbol because it gets confused with the variable x. So we have decided not to use that. I have 3 times x is equal to 21. Well, what times 3 is equal to 5? I know that, it's 7. So we're going to do the exact same thing. We're going to find these solutions, but instead of using intuition, we're going to use our algebra. And I know it seems sort of redundant because we know how to do it and we find the answer, but like most things in mathematics, it's not really about the answer, it's about the process underneath the answer. So x minus 4 is equal to 7. Our rule, recall from last year, is that if I want to find out what x is, if I want to solve for the variable, I need to have it all by itself on one side. So I need to end up with, down here, x is equal to something. But there's a problem. I don't have x all by itself on this left side. This negative 4 or subtract 4 is in the way. So in order to solve, we want to isolate x, or isolate the variable. It's not always going to be x. And we want to do that by using opposite operators, which means whatever we're doing to the x in the equation, we want to do the opposite. So what's happening to this x? Well, it's being subtracted by 4. Well, what's the opposite of subtracting by 4? The opposite of subtracting 4 is adding 4. And that makes sense. If I have any number and I add something to it and subtract something to it, I end up exactly where I started. So 2 plus 5 is 7, minus 5 is 2. It's almost like the positive and negative 5 cancel each other out. So I want to add 4 to the left side, and that's going to cancel out with the subtract 4. So they're gone. But like we talked about with the scales, now this equation is not balanced because it was balanced before, but now I added 4 to the left side. Suddenly this side is going to be heavier than this side. So whatever I do to one side, I also have to do to the other, and I do the exact same thing. So I add 4 to the left, I add 4 to the right, I bring my equal sign down exactly where it was, just below it. What's left on my left side? Well, all I have left is x. What's left on my right side? Well, I have 11. Which is the same answer I came up with intuitively. Here we just use the algebra. Down here, what's happening to this x? Well, it's being divided by 4. What's the opposite of dividing by 4? It is multiplying by 4. Not multiplying by negative 4. That only works when we're talking about sum and differences, adding or subtraction. If we're dividing by 4, the opposite of dividing by 4 is multiplying by 4. So we're going to multiply x by 4 on this side. And it's the same as with adding and subtracting. If I take any number and I multiply it by something and divide it by the same thing, I end up with what I started with. So 2 times 4 is 8, divided by 4 is 2. So it's like they cancel each other out. But I can't multiply the left side by 4 without also multiplying the right side by 4. So I'm going to multiply both sides by 4, and I'm going to get, on the left side, these cancel each other out. I'm left with x, because 4 divided by 4 is 1x, and that's just x. 25 times 4 is 100. And that's what I had over here. Down here, this means 3 times x. The opposite of multiplying by x is dividing by x. You can represent dividing by 3. You can represent dividing by 3 like this, but we sort of like to use fractions because you're going to see fractions a lot. So we're going to use This is x times 3 because we're multiplying x by 3, so I'm going to divide it by 3. I can't do that on the left side without also doing it on the right side. These 3 divided by 3 is just 1, and I'm left with x is equal to 21 divided by 3 is 7. So let's go back to our scales. And let's do the exact same thing we did down there, but let's do it up here. And in this case, this is going to be our first two-step equation. And when we do two-step equations, now we have multiple things we have to get rid of. So not only do I have this x being multiplied by 2, but then it's also being added by 3. And if I were following BEDMAS, I would have to say that the first thing I apply to the x is brackets, exponents, I don't have any of those, division, multiplication, they're together, I can do them in any order from left to right, and addition, subtraction, which I do from left to right in any order. So BEDMAS, I would normally take this x, multiply it by 2, and add 3. But that's when we're trying to simplify. When we're trying to solve, when we're trying to isolate, we actually go the opposite way. We actually do the last thing first. So if the last thing I would do is adding 3, that's the first thing I do when I'm trying to get x all by itself. So we don't follow BEDMAS, we actually follow SAMDEB. So we're going to deal with subtraction and addition first, and then we're going to deal with multiplication and division, and then we'll deal with any exponents and brackets that we have after that. So here I have x, it's being multiplied by 2, and then we're adding 3 to it. Well, I'm going to deal with subtraction and addition first. So this is a plus 3, so we're adding 3. The opposite of adding 3 is subtracting 3, but I can't do that on the left side without also doing it on the right side. And so I have positive 3 minus 3, that ends up being 0. And then I have 7 minus 3. So I'm going to move my equal sign down right below it. On the left side, I'm left with 2x. And on the right side, I have 4. I have one more step now. I still have this x being multiplied by 2. What's the opposite of multiplying by 2? Dividing by 2. I also have to do that at the right side, because whatever I do on the left side, I also have to do to the right side. 2 divided by 2 is just 1, so that's 1x is equal to 4 divided by 2 is 2. So what's in each bag? 2 cubes in each single bag. All right, let's practice that some more. I have 2x plus 1. I'm going to follow SAMDEB. So I'm going to do my subtraction addition first. So I'm dealing with this addition right here. That's 2x plus 1. The opposite of adding 1 is subtracting 1, but I got to do it to both sides. 1 minus 1 ends up being 0. So 2x plus 0 is just 2x on this side equals 5 minus 1 is 4. And I got one more step. This is 2 times x. The opposite of multiplying by 2 is dividing by 2. I'm going to do that to both sides, and I have 1x, or just x, is equal to 2. And the nice thing about solving is I can always check my answer. I can always check my answer by going back to the original equation and seeing if this works, seeing if I can actually make the equation true when x is equal to 2. So instead of x in here, I'm just going to put in 2. So I'm going to put in a 2 in there instead. So 2 times 2 is 4, plus 1 is 5. Yep, that works. I've double-checked my answer, and we're good to go. So, same idea, but this time we have a division in the way. But I'm still going to use SAMDEB. So subtraction addition first. So I'm dealing with this negative 2 first. The opposite of subtracting 2 is adding 2. So I'm going to add 2 to both sides. Negative 2 plus 2 is just 0. X divided by 3 minus 0 is just x divided by 3. So on this left side, I'm going to x over 3 is equal to, I always write my equal sign right underneath, 1 plus 2 is 3. Now, What's happening to this x? Well, it's being divided by 3. So now I can deal with my multiplication and division, although it is the only thing left, so it is the only thing I can deal with now. X divided by 3, the opposite of divided by 3 is multiplying by 3. So I'm going to multiply both sides by 3. And I'm going to get 3 divided by 3 is just 1, so we're left with x on this side is equal to 9. And I can double check to see if that works. X over 3 minus 2 is equal to 1 was our original equation. I'm going to substitute 9 in for x. So I'm going to put 9 in here instead of x. 9 divided by 3. So now I'm simplifying. So now I don't follow SAMDEV, I follow my math rule as normal. So 9 divided by 3 gives me 3 minus 2 is 1. Perfect, that works. I've double checked my answer and I know I'm getting full marks. Last one. So now I have a multiplication and division. And the issue here is I have no subtraction or addition, so I have to skip that entirely. I'm left with multiplication and division. Now, you can do multiplication and division in any order, typically, unless you have an expression in the numerator, but we're not going to cover that till later on in the course. So right now, I just have this t, and this t is being multiplied by 8 and divided by 3. And because they're both either division or multiplication, I can deal with them in any order I want. So let's just say I'm going to deal with that multiplication of 8 first. So this is t being multiplied by 8. So the opposite of multiplying by 8 is dividing by 8. So this is 8t is equal to, oh, I didn't make it equal to anything. So let's restart. Let's make this expression equal to something. So 8 over t, let's make it 24. So I have t times 8 divided by 3. I'm going to multiply, or I'm going to divide by 8, because that's the opposite of multiplying by 8. So I'm going to divide by 8. But whatever I do to the left side, I have to do to the right side. So I'm going to divide by 8 here. Because I'm multiplying by 8 and dividing by 8, they cancel each other out. So it just ends up being 1. And 1t is just t. So I'm going to write my equal sign down below. All I'm left with here is now this t divided by 3 is equal to 8 divided by 24. Well, that's going to give me 3, 8, 16, 24. And then I have t divided by 3 is equal to 3. The opposite of dividing by 3 is multiplying by 3. And whatever I do to one side, I have to do to the other. So t times 3 divided by 3, these 3's cancel out. All I'm left with on this left side is t is equal to 9. And I can double check that out. 8 times 9 divided by 3, is that equal to 24? It sure is. 8 times 9 is 74 divided by 3, so that's 24. That checks out. I know that my answer is right. Let's do the same thing, but we're going to do it in the other order. So I have 8t divided by 3 is equal to 24. In this case, I'm going to multiply by 3 first. So this is t divided by 3 times 8, or t times 8 divided by 3. I can do multiplication and division in any order. But in this case, because this is t divided by 3, I'm going to multiply by 3 first. So I end up with the 3's canceling out. I end up with 8t on the left side. So 8t on this side is equal to 72 on this side. And my last step, this is t times 8. So I want to get rid of that 8. So the opposite of multiplying by 8 is dividing by 8. And whatever I do to one side, I do to the other side. And I end up with t, which is equal to 72 divided by 8 is 9. That's it. What I don't want to see, which I see all the time, is this is something you learn in elementary or in grade 8, but if you have 2x plus 2 is equal to 20, let's say, you've learned to take this positive 2 and move it to the other side and change the sign. That does not work. I cannot grab the number. I cannot move it around. It's stuck to the paper. I can't just pick up a block from one side of the scale and put it down on the other side of the scale. Even though it does work for addition and subtraction, it starts to break down when we talk about all the other operations and when equations get more complicated. So don't think about it in terms of moving things to the other side. Think about it in terms of using an opposite operator to cancel things out. That's it. We'll move on to multi-step equations. If you are struggling with this stuff, I know that it's the weekend and things are due on Sunday, but I'm around all weekend. So if you do need some one-on-one help, just message me. I can always jump on. We're all in quarantine, so there's really nothing else to do. I'm home all day. And I will talk to you early next week.